What I've tried to emphasize in this class so far is if you're working problems, kind of focus on the units and kind of drag the numbers along with the units. Set up your units and then things fall into place. We've been talking about molar mass. By the way, I didn't tell you about it yet, but molar mass, my abbreviation is MM. That's my abbreviation for molar mass. The units of molar mass, we said, are grams per mole. So looking at just the units, I don't have any value there, but just the units, do you see where we can actually use this as a conversion factor? We can slip it in to go from grams to moles or moles to grams, and we're going to work some problems like that. So we're going to pick on calcium first, and just take your time reading problems. It says how many moles of calcium atoms is 0.487 grams of calcium. Now again, what I did in brackets before, usually this won't be here, so it will say how many moles is 0.487 grams of calcium. So how many moles, question mark moles, is 0.487 grams of calcium. So you need a link between grams and moles. If you look at the periodic table, you're going to see that the decimal number for calcium is 40.08. That means in calcium there's 40.08 grams per 1 mole. We could go ahead and set that up like this. This is what I call kind of unpacking the molar mass. Again, it's a specific property of calcium. That's the way I look at it. We could go ahead, and the inverse of that is true. The difference between these two ratios is just one is flipped. So we could say that 1 mole is equal to 40.08 grams of calcium. We could flatten it out like this. So these are all three ways of kind of looking at the molar mass of calcium. So let's go ahead and work the problem. Let's see, how do I say this? The molar mass is not going to be our first term. Our first term is actually going to be the thing we want to convert. Okay, so we are going to go from grams of calcium to moles of calcium using the molar mass of calcium. 40.08 grams is equal to 1 mole of calcium. And where did we get this information from? We got that from the periodic table. Exactly. All right. So the first term is going to be the thing we want to convert. We're converting from grams to moles. So I would go ahead and put that over 1. And then do you see where I would go ahead and put in my units? I want grams to cancel. I want to be left with moles. And so do you see where I would put 1 mole up here and 40.08 grams down here? Does that work? I think so. Units of grams cancel. We're left with units of moles. Now, how do we need to round this? How many sig figs? There is uncertainty brought by this term, and there is also uncertainty brought by this term. So we need to round according to 3 sig figs. So I get, I get 0.0123 moles of calcium. Very good. That actually is what we call a grams. That's your first grams. Maybe not, but that's your first grams to moles conversion using the molar mass for the element. All right, let's do another one, and we're going to switch it up from calcium to boron. So it is, looks like this, what mass, so question mark grams, is 1.33 grams of boron. Now notice that this thing in atoms of boron atom, the word atoms probably won't be there, it's implied. So we're going to have to use the periodic table to look up what the molar mass of boron is. So that's the molar mass of boron. We can go ahead and unpack that to look like this. We can flip it to look like this. We can flatten it out to look like this. So these are all saying the same thing for the element boron, the property. It's a molar mass of boron. All right, so we're ready to work this problem. And again, here's what the strategy looks like. We're going to go from moles to grams using the molar mass. So the first term is not going to be the molar mass. It's actually going to be the moles of boron over 1. Put grams over 1. And then I want units of moles to cancel. I want to be left with units of grams. So what does that look like? It looks like 1 mole on the bottom and 10.81 grams on top. I'm liking it. So units of moles cancel. It's all about getting units to cancel. And we're left with units of grams, which is perfect. So is there any uncertainty brought by the first term? Yes. Is there any uncertainty brought by the second term? Yes. All those those decimal numbers on the periodic table are rounded. All right. So I'm liking 3 sig figs. And rounded to 3 sig figs, I got 14.4 grams of boron. So this is what we would call what? A moles to grams conversion using the molar mass of the element.